Hello and welcome to Sharda e-learning educational video tutorials. We are going through mathematics part 1 from which linear equation in two variables. We have seen the methods of solving linear equations which are elimination method, graphical method and determinant or Cramer's rule method. Now we are going to see our next part of this topic, which is equations which are reducible to a pair of linear equation in two variables. Equations which are reducible. Reducibles means change or convert. So, for example, if we have equation of this type, 3 upon x, 3 upon x minus 4 upon y is equal to 8. This is also an equation, but can you tell whether it is a linear equation or not? We can see there are two variables x and y, so we can call them as equation in two variables. But are they linear? Are they linear? What is meant by linear is they must have power or degree 1. They have degree minus 1, not 1. 1 by x is also can be written as x raised to minus 1. So they do not have the linear degree, so we cannot call them linear, so they are not linear even if they have two variables. They are not linear. Similarly, another example, 6 upon x minus 1 plus 3 upon y minus 2 is equal to 0. This is also not linear equation because they do not have the degree 1. So we found out that these are not linear equations. But the question arises, can we convert or reduce them to a linear equation in two variables? Can we convert? The answer is yes. We can convert in some cases, whether some cases if they have suitable variables. Yes, so we will see how to reduce them to a pair of linear equation. So in the above equations which are not linear, they can be converted to linear equation by making suitable substitution. How we can convert them? By making convert or reduce them by making suitable substitutions. Suitable substitutions. Okay. So what are the steps for solving equations reducible to a pair of linear equation? What are the steps? So steps number 1 is select suitable variables other than those which are in the equation. What is step number 1? Is select suitable variables other than those which are in equation. Means the equations containing x and y will be replaced by another variables like a and b. But you should not take the same variables to replace them. You should select other variables. Okay. So this is the step number 1. What is the step number 2? Replace the given variables with new variables such that the equations become linear equation in two variables. We can, after selecting the variables, just replace them in the equation. Step number 2. What is step number 2? Is replace the given variables. Given variables means the variables which are in the equation, original equation. Replace the given variables with our new variables so that the equation become linear equation in two variable. Okay. Then step number 3. What is the step number 3? After replacing the given variables with our new variables, solve the new simultaneous equation and find the values of new variables. Then after replacing, solve the equation, solve the new simultaneous equation, and find the values find the values of new variable. Of course, if you are replacing x and y with a and b, then you have to find the new values of a and b, values of new variables. Okay, this is the step number 3. Then step number 4 is our final step. By resubstituting the values, resubstitute it, the values of new variables, and find the replaced variables. So what is the last step is convert them in the original variables. We have already converted them to new variables. Then we find the solutions. Then in the last step, we resubstitute the values of new variables and find the replaced variable values. Okay. So we can understand this by taking an example. Okay. We will see the steps again and we will try to solve an example. Example 4 upon x plus 3 upon y is equal to 1. This is our first equation. Then second equation is 8 upon x minus 9 upon y. This is our second equation. So, are these linear in nature? Before substituting, these are not linear equation because they do not contain the degree 1. But we can reduce them to our linear equations in two variables. So for them, these are the steps we should follow. What is the step number 1? Is select suitable variables other than those which are in the equation. The equation contains variable x and y. So we will take the variables p and q for replacing them. But what should we replace? We should replace the common in both the equation. We should find what is common in both the equation. We can write this equation number 1 as 4 into 1 upon x, right? And then 3 into 1 upon y is equal to 1. Similarly, we can write this equation as 8 into 1 upon x, 9 into 1 upon y. So we can see they have this common variable format. 1 upon x is also in equation number 1 and equation number 2, right? Similarly, 1 upon y is in equation number 1 and equation number 2. So we can replace them. What we can replace it for? So new variables, take new variables. Let p is our first variable, first new variable, is equal to 1 upon x, and q is equal to 1 upon y. Why are we doing this? Because they are not in linear format, but this is in the linear format. This has a power 1. So we are doing it for making the equation linear. But how we are going to do is watch the similar part in both the equation. 1 by x is common in both, 1 by y is common in both. So we are replacing it with our new variables p and q. By replacing means you have to change them in the equation. If we are changing them in the equation, how the equation turns? So equation 1 and 2, these are the equation number 1 and equation number 2, now become, by after replacing 1 upon x, 1 upon x should replace it with p. So what it gets is 4 into p. Then plus 3 into q is equal to 1, and 8 into p minus 9 into q. So these are our equation number 3 and equation number 4. So this is the step number 2. What is it? So replacing them with our new equation, sorry, new variables in the equation. So now we got the linear equation in two variable. Now we can solve them by our methods. What are the methods? Method elimination method, graphical method, and determinant method. So here we will use the elimination method. We can see elimination method is easy when they are seen reducible. Okay, why they are easy to solve with reducible? Because we can see here is a 3q, and in second equation there is a minus 9q, minus 9q. So if we multiply equation 1 with the 3, this will become positive 9q, and it can be cancelled with the minus 9q. So we will multiply equation 3 with 3. Equation multiply with the 3. So what will happen is the equation 3 will become 12p plus 9q is equal to 1, and equation 2 will become as it is 9q is equal to 7. Right hand also will be changed. it will become 3. So after adding these equations, equation number 5 and equation number 4. So after adding these equations, we will simply get 20p is equal to 10. P is equal to 1 by 2. Okay, P is equal to 1 by 2. P is equal to 1 by 2. P, if we put P is equal to 1 by 2 in any of equations earlier we have written, equation number 3, suppose equation number 3, if we put P is equal to 1 by 2 in equation number 3, what was equation number 3? 4P plus 3, Q is equal to 1. So 4 into 1 by 2, I am putting P is equal to 1 by 2 plus 3, Q is equal to 1. Because I am going to solve it for Q, I will keep them at one side. What is the remaining side? 2 will be get on other side. Q is equal to minus 1 by 3. So we get the values of our new variables. These are not original variables. Original variables are x and y, right? These are the replaced variable. Now the step 4 comes in. What is the step 4? We have to resubstitute these values in our original variable. What was the original variables values? We have written P is equal to 1 upon x and Q is equal to 1 upon y. So what is the value of P? P is value 1 by 2. P's value is 1 by 2 and is equal to 1 by x. So x is equal to 2, right? X is in the division here, it will multiply here, this side, and 2 will be multiplied by 1. X is equal to 2. Similarly, Q has minus 1 by 3. Q has minus 1 by 3 value is equal to 1 by y. So y is equal to minus 3. So we will write our last sentence, x comma y ordered pair is equal to 2 minus 3 is the solution of the given simultaneous equation. So these are the steps we required to reduce a non-linear equation to linear equation and solve them using our linear equation solving methods. You can use any other method. We used here elimination method. Elimination method is relatively easy and non-complex method other than other methods. But you can use any other method also to find the linear equation solution. So we will see the next part, which is application of linear equation in two variable in our next video. Thank you very much.